Welcome back again to the PLC Professor Presents How to Program a PLC. This is the third part, or Volume 1.2, and in the first part, .0, we examined a garage door opener electrically, and then in point 1, we introduced the tools and memory locations that you're going to be working with in a programmable logic controller, MicroLogix 1000. And in this section, this next segment, we're going to go through and we're going to write the program. And once again, I will say, if you don't understand what's going on, if you don't have like an 80%, 70 to 80% comprehension, you need to go watch some of the other videos that are free on the PLC Professor YouTube channel. There's Basic Electricity, and there's a whole bunch of lectures that take you up step by step to understanding relay ladder diagrams or relay logic and PLCs. So welcome back, and now we're going to write the PLC program. This is an unrehearsed, unscripted recording. We're going to do an actual screen capture, not of a PowerPoint, but of using MicroLogix or RS Logix MicroStarter Lite, which is really a stripped down version of RS Logix 500. And again, this software is free. The PLC is not free. They're about $125, $130. However, you can download RS Lynx Lite and RS 500 Emulate free from the same page that you download this software. I have a video on the PLC Professor YouTube channel that tells you how to create a simulator. If you go there, it'll give you everything you need to do exactly what I'm going to do right here, only you won't have a real PLC, but it will behave like one. So we're looking at RS Logix MicroStarter Lite. And the first thing we're going to do is we're going to create a new file. And remember, we're creating an offline file that we will later download part of the file to the actual MicroLogix. You can see here the processors that are available or supported by this version of RS Logix. So we'll pick the MicroLogix 1000, say OK, and voila, there's your project. Now you recognize this from the second segment of this series, where we talked about these are your toys, this is where you play, and these are the tools to put your little Lego pieces together to create something. Or these are your physical memory locations. There's the ladder files and there's the data files. Okay, and the data files are what we're really most interested in. And then this is the area where you connect up those physical memory locations here. And these are the tools that you use to do that. So I'm going to go over here and I'm going to double click on output file 0, and I'm going to go up here to the upper left hand corner, click, and I'm going to lock this on top. Okay, now what that does, it locks it on top so it doesn't disappear if I click someplace else in the image. Okay, so we can drag that anywhere we want, and we'll just drag it over here, and then I'm going to go double click on the input file. I'll lock it on top. Okay, so there's your inputs, outputs. If you don't like the fact they're not the same size, you can adjust that. I like things nice and even and tidy, personally. And then B3, double click on that, do a lock on top, and then drag it up, because we really don't need 32 words, 16-bit words. Okay, so we'll just leave 2 showing, and I'm going to stretch this out so you can see that there is a position to show the symbol and the description. A symbol is a unique identifier that points to this B3:0/0. That's actually a pointer. It points to a memory location you really don't know where it's at. So the symbol points to a pointer that points to the real memory location. for all intents and purposes, let's just say that B3:0/0 is a physical memory location, even though it's actually a pre-declared variable that points to that location. Okay, so we'll drag this over here, and now we got our primary players. Now, what I'm going to do is to pull these out of the view, and maybe we'll pull them back later. So, looking at your wiring diagram, and by the way, I should have mentioned it wouldn't hurt for you to sketch out the wiring diagram from the first segment. This is the third segment. Sketch it out so you can use it to follow along with what we're going to do. And I'm going to make the relay ladder diagram look almost exactly like the wiring diagram, even though that's not how I would do it if I was writing a program. In other words, I might not put the rungs in that order. So we're going to start out, and we need a rung. So you can go up here, and by the way, the focus, see how it kind of changes color? If your focus is over here, you can't do anything with this. So you click over here, anywhere over here, and then if you click there, see, it'll give you a new rung. I'll delete that, and I'll grab it and drag it down. So you can drag and drop, or you can just click. So I'll drag it down and drop it. Okay. Now, if you're looking at your wiring diagram, we need a what looks like, but it is not a normally open contact, but it looks like it. And then we need something that looks like a coil, and we need another rung. I just clicked on it and it popped down there. It's always going to pop down after. And by the way, you can move them later. See? So we'll leave that there, and we'll do another one of these. Now, let me show you something else you could do. I'm going to delete this one. Okay. Instead, I'm going to right-click on the head of the rung, copy, right-click, paste. So you can cut and paste just like in a word processor. Now we need another rung, so I'll drag a rung down, and I need a what looks like a normally closed. Actually, this is a good learning spot. It's a normally closed push button, the stop button, but you don't use a normally closed or a true if off to examine a normally closed to see if it's on. So that's actually going to be a true if on, because we want to know if the normally closed push button is closed. If it's closed, the bit memory is on. This instruction will be true if the bit memory is on. Okay, then we're going to add another true if on. Then we're going to branch around it. See right there? Rung branch. And then we're going to take and drag it over here to a green, I call them memes. Pick me, no, pick me. This little stupid humor. And I'm going to put another true if on. Then I'm going to do another true if on. And a true if off. And what looks like a relay coil. Okay? And now I can copy this. Control C, click, Control V. Remember the first time I did a right click, copy, right click, paste, but you can do Control C, Control V. Believe me, when you start doing a lot of this, you'll find ways to zip right through this. Okay. Now the electrical timer, we're not going to be able to make this logical timer look like the diagram does, but we will still put it in that order. So as we were saying, we need to add a timer now. So we'll drop down a rung, or I could have drug it down, and then we need, and this is going to surprise you, but hang in there, 2 true if offs, and we need I'll drag this one down for you. See? Look at all the memes. Now I can put it here or I can put it over here. It's still going to go the same place. It's still going to go all the way over to the right because it's an output type instruction. It's a action, not a permissive. Okay, so there's our timer. And in this case, because of the way we did the logic, and by the way, I will drag down the next rung. So I go up here. So you have these tabs: user, bit, timer counter, input, output, compare, compute, math, on and on and on. So user, this is one that you can configure. You can add your own favorites in here. So I'm going to click and hold down and drag down a rung. And I'm going to drag down a true if on, and I'm going to drag down an output, or a OTE, output energize. And again, I can put it here. I can drop it here. Okay, it'll take it, but it won't accept it. You can't have the output before the input. You can't have the action before the permissive or the condition. So I'll just grab this bad boy and drag it over to this Mimi or that Mimi. It doesn't really matter. Let go of it. Okay, so this timer instruction will instruct a timer data type that will control this bit, which will control this output to turn the light on and off in the garage. Okay, so we don't need to draw power for anything because this is all logic. In other words, in our electrical diagram, we had at the bottom rung, wiring rung, we had the photo eye. That was electrical power to operate the photo eye, and the actual contacts were someplace else. As a matter of fact, the actual contact was in this rung right here. So we actually, this would be the limit switch, and this would be the interlocking contact from this coil down here, interlocking contact. However, we need one more condition here for the photo eye. So now let's go back and put some memory locations to associate with these instructions. Now ordinarily I would not write my logic like that. I wouldn't create the whole diagram, okay? But if you did go do a sketch of the wiring diagram, it looks pretty much just like this, okay? Now, what I'm going to do is I'm going to delete. If I put my cursor at the head of the rung and hit the delete key, she's gone. Ooh, if I don't want to do that, right there's an undo. Undo, 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 undo. Redo, redo, redo. Okay, if I was going to write this logic from scratch and no one was paying any attention, I was just doing it, I would put in a rung and put in a true if on. Okay, and I would probably put in the output device. Now I'm going to do this first with all internal bits, B3s. Then I'm going to turn around and change some of the memory locations to the ones that are electrically, physically associated with actual field wiring. So I'll just pick the first bit in our B3 file. So, and by the way, MicroStarter Lite is very intuitive. It has type forward. It's a very, very, very well massaged, well developed graphical user interface. So I'm just going to type in B3, but I need a delimiter if I'm going to switch from file to Word. So I don't have to put in a colon. I can put in a semicolon because the software is smart enough to know that that's a delimiter. Okay, and then I'm going to put in word 0 / bit 0. And when you hit enter, notice that it changes it so it's a colon. So if you come even close to the actual format for the memory location pointer, it'll put it in for you. Okay, so I'm going to give this a label because Otherwise, you know, those pointers don't mean anything to us. They're just physical locations in memory. So I'm going to call this up relay, or CR. We'll be a little bit more wordy. Contact control relay up. Okay, and this of course is going to be oops, I typed it in the wrong place. I typed it in the symbol. I don't want to do that. And that was because, see, this is a good mistake for you to see. By the way, I write the actual work that I do, that I get paid for, is 100% control logics, compact logics, soft logics, etc. It's all RS Logics 5000. So I have grown accustomed to a completely different structure in how you create your pointers or your variables. And so I will probably make a few mistakes forgetting that I'm using RS Logics 500. So in RS Logics 500, if you want to put a man readable, you first have to give it a pre-declared variable memory location. So I'm going to pick B3 :1/0. I'm going to use a different word. I'm going to use word 1 instead of word 0. Okay. Now it wants a description. Motor up. Okay. So there's our first rung, and just for grins, I'm going to accept this. Now we are offline. As you see right here, we're offline, but I hope this doesn't turn around and bite me doing it in this order and embarrass me, but I'm going to, you could right click here and say verify rung. I'm not going to. I'm going to go verify the whole project, or actually the whole file. I'm going to click there. See, the E's disappeared, which means it's happy. By the way, I don't like that dark gray because, I mean, I like it when I'm actually writing programs because I don't need to see what it says. But I'm going to go change it for you. You see how I did that? I right-clicked in an empty spot, pick properties, go to colors, and I go to selected. See, it's dark gray. I want to make it, and I hate a lot of colors, so I'll just pick light gray. That's better. Okay, so what I did was I verified this rung. Now, verification means that when you come up here and you click verify file or verify project or right click and verify rung, you're telling RS Logics 500 or RS Logics MicroStarter Lite, you're telling it to look at your syntax, your structure, and see if it's acceptable. In other words, if it'll do what you want it to do, because it's not a mind reader. It's just, is it an acceptable format supported by this software? So now we're going to download this. So we go up to comms, system comms. Now I'm assuming you already have, if you're following along here, or if you're going to do this, that you have a RSLinks driver already configured. See, I already have it configured. There's my bad boy right there. It sees it. See, this is browsing. Looking. Finds it. So I can click here or here. It really doesn't matter. And I'm going to say download. Wants a name. So we'll call this how to, oops, how to program. And since we might do this more than once, we can throw an underscore and a 1 on there. You have a lot of latitude in how you name these files. So I'm going to save this file. Downloading program. Are you sure you want to proceed with the download? You bet. Processor's in the run mode. It must be switched to the remote program mode. Now, if you have a processor right there in front of you and you have a switch on the processor to switch it between run, remote, and program, well, then you can just reach over there and do it. I always prefer to do it from here. So really what this is asking is your permission for the development software to switch the mode. And I say, yeah, go ahead and switch it. Okay, because it can't download while it's running. Okay, kind of hard to eat while you're running. Change back to the run mode. It's asking permission, yes. Okay, do you want to go online? Yes. Now you see we're in the remote run mode. You see this little ladder thing here rotating? That's a good indication that you're in good shape. Now here's what I wanted to show you. In your wiring diagram, this is a relay contact, but it's not here. This is a true if off instruction. In your wiring diagram, this is a relay instruction, a relay contact. If the relay energizes, this goes closed and turns on the motor. So I'm going to toggle this bit on and watch what happens over here to motor up. It goes on. So I didn't flip a switch. All I did was from the keyboard and this graphical user interface that gives me access to the memory locations, I turned on that memory location, which turned on this memory location. This is true if on. That bit is on. I just turned it on. The rung is therefore true, so it turns on this bit in memory. Now whether this is a contact from a real switch and this is a coil of a motor, it doesn't make any difference. The logic is the same. It looks the same. And this is one of the advantages of relay ladder diagrams or relay logic, is that it's so closely visually, because men are very visual, and ladies that are watching, you're smarter than us guys, so you got to suck up a little to the ladies, guys. Anyway, so this is just all easy for y'all. Okay, so I'm going to go back offline because I'm nowhere near done. I just wanted to show you that whether you're using an actual field device to turn on this bit, to turn on a field device by this bit, or you're just turning on this bit and it turns on that bit, what takes place in the PLC is entirely in memory. It's entirely in the data table. So I can go up here and go click on that little drop down, say go offline. Save changes, why not? What changed? The bits in the data table, right? I don't need a revision note. Now it's reading in the executables, reading in the data tables. Now notice that this is still on. It wasn't when we downloaded, only after we downloaded and toggled it on. So now I'm offline now. See? Offline. If I go toggle this bit, if we were online, you would expect it to turn off that bit. But it doesn't. Because now our graphical user interface wiring programming diagram here is animated by the offline data table, and there's nothing manipulating those bits. So let's go add another rung just like this. So I'm going to I click on the head of the rung, then I go Control C and then Control V. Voila. Now I'm going to go change this to bit 1. I double clicked on it, reverse videoed it. Remember, it turned dark blue with white 0. Hit enter. Now it's asking for a description. I'm going to move this aside and I'm going to type in control relay down. Okay, and I'm going to go over here, double click, put in a 1. That's interesting. I must have clicked real fast there. I didn't get a chance to put in a description. So I will right click, edit description. I must have bounced that key right on past there. It doesn't matter. This would be motor down. Okay, so there's our two rungs to control the motor. However, they're controlled by those two relays, and we don't have anything controlling these relays yet. So I can go verify this now just to see that it likes everything. Now, if this were RS Logix 5000, as soon as the rung is happy, RS Logix 5000 is always looking at the syntax. And once the rung meets the requirements, the E's disappear. You don't have to go verify it separate. But we're not doing 5000, we're doing 500 right now. So in my next rung, I need the stop button, and then I need a start button or a up button, and I need to go around that with a contact from the up relay. So I put another contact in there. Then I have a contact from the limit switch. Then I have a contact from the other relay. And then I have the relay itself. So this is the stop button. So we're going to let this be, I'm going to get greedy here and I'm going to use a third word. And so this will be B3:3/0. We'll pull that out of the way. And that is the stop push button. And then this B3:3/1 is the up push button. This is the, well, before I put this in, remember that this relay coil controls that contact. So all I have to do is drag this down to here. Because when this bit turns on, that instruction is true and turns on that motor. When this relay is energized, that contact closes and turns on that motor. But remember, this is true if on. It's not a normally open relay contact. But because we're making a transition from an electrically controlled circuit to a logically controlled one, I'm going to mix them a little bit. Okay, also, this is the same device there. So all three of these devices, normally, if this was a relay coil, this would be normally open contact of that relay, and this would be a normally open contact of that relay. Okay, you get the drift. Now this is a limit switch. So we'll let this be B3:2, and we'll call that limit up switch. And we can put an underscore in there if you like to fatten it up a little bit, make it easier to read. Limit up switch or limit up switch. Just depends on how you like to do your grammar. Now this is a contact from the next rung, which we don't have yet. So we'll go ahead and we'll go Control C, Control V. Okay. Now, this is the same stop button as this. And you can do your logic this way if you like. No, we're going to go ahead and do it that way just to keep it simple. In your electrical diagram, you show one stop button, and then you would branch around all this and put this next rung. We're not going to do that. We're going to keep this logic easier to read. But this is one and the same stop button. It's the same memory location, right? However, this is now the stop or the down button. And so this is going to have to be the next unused memory location. We use B332, so this can be B333. And it did not give us an opportunity to edit the description. Now, if there's already a description for that bit, then it won't give you the opportunity. So this is down push button. By the way, I put an underscore in here. A description doesn't have to have an underscore. So that's a habit to put in that underscore for tag names in 5000. You see here I got away with a space. A space will work there too. But we'll just leave it that way. Okay, so this is our down push button. This needs to be our limit down switch. So this is B3, 1, and 2. This would be B3, 3, and 4. We'll put in a 4. Now there's a different memory location. Right click, edit description, and we'll call this limit. We'll leave out the underscore and just use a space down switch. See, both work. If you don't like this, double click on it, backspace, space, and, whoops. You can't use an enter instead of OK here. You have to hit OK. Now, this, let's see, B300, let's see if B301 is used. Put in a 1. Oh, that's right. We already defined it up here, didn't we? Control relay down. So we've already defined that bit. So now what we have to do is drag this one down to here. And whoops, I'm getting a little wide with our rungs there, so I'm going to drag this over and then drag this one up here. That gives us our interlocking logic. And I'm going to hit verify the file. Now notice that these look exactly like, more or less, the wiring diagram. Okay, this is stop for either up or down, up limit switch, interlocked with a control down relay, interlocked with a control up relay. So down, down, up, and I see one mistake here. Now this is real easy to do because it looks like it's all wired up, and technically it is logically connected. However, we want this, they're not, well, I don't want to grab the whole instruction. I just want the address, okay? Because that's control relay up, that should be control relay down. Remember, this seals in the down push button. See, up, down, down. That's a very easy mistake to make when you're editing logic, because it looks like it's done, but it's done wrong because you copy and pasted. I'm sure you've done that in your word processor. You copied something and you forgot to edit the one word that needed to be changed. Because remember, this is all text. Just to prove that, I'll verify this. Now watch up in this area. I'm going to double click here. You see right there, XIC, true if on, memory location, branch start, XIC, memory location, next branch, memory location, branch in, which is this right here. And then here's your limit switch right there, true if on, memory location, true if off, interlocking relay, and then output energized memory location. So each rung is a sentence, or it's a text string. And when you save the project, it saves it as a text string, not in this graphical user icon based form. Remember, ladder logic is something that allows us to visualize the logic the way we would visualize an electrical diagram. Okay, we're hitting about 25 minutes, so I'm going to speed up a little bit. Okay, so I thought there we go. Oh, I put it in the edit mode. So now we have those two rungs done. Now we need the timer. Okay, so I'm going to drag down a rung. I could put it here, I could put it there, I'll put it there. And we need a 2 true if offs, And then we need a timer instruction. And I'm going to use, I need control relay up and control relay down. So these would be additional contacts from these two relays, okay, if this were relays. Now you're probably wondering why in the electrical diagram they were wired in parallel and here they're wired in series. That's because in the electrical diagram I used an off delay. Here I'm using an on delay, and you'll see shortly how this works. Okay, so my timer, it's a timer instruction, but it doesn't know who to instruct. So I'm going to say TON, timer on delay, I want you to instruct T4:0. Enter. Okay, and we'll call this illum delay, or we'll call it illumination off delay, because that's what we're doing. We're delaying the illumination going off. Okay, now, and we'll leave it 1 second, but you see that you have some choices there. Now, I don't know that it'll accept 1/1000th of a second or 1/100th of a second. Usually the MicroLogix 1000 only has 2 time bases, but we're going to leave it 1 second because that's what we're dealing with when we're talking about delaying the light in your garage going off. Okay, so we can verify here, and it's a happy rung. Now we need to add another rung. You see I was on timers and counters, and I went to user, added in a rung. I'm going to put in a bit that's going to be controlled by this timer data type, and then a bit that's going to control the light. So I'm going to cheat. Technically I should type in T4:0.TT. Well, I'll just do that. T4, it doesn't have to be colon, semicolon, because it knows what you want, 0.TT. That's the timer timing bit. If you don't know what that is, you need to watch the lectures and do the labs on timers. And we're not going to give this a separate name. We could, but we'll just let it carry the name from the actual timer, illum off delay, okay? And then here we need another output, and I think B302 might be available. B30/2. Yep. This is our garage illumination, garage light, lamp, whatever you want to call it. So this might be done. So just for grins, and we used all internal bits here, so we don't have to have any switches to run this. And remember, if you're using the simulator instead of an actual hardware PLC, then you pretty much have to toggle the bits to run this logic. So I'm going to go, well, I'll save it first, but I'm not going to give it a revision note. Okay, saved it. Now I want to download. I can go from here, but that's kind of like pinning the tail on the donkey. It's going to use that driver and go to that location. And although in our situation that's fine, where you have multiple processors, it's not a good idea. So I'm going to go to comms, system comms, because me an RS Who looking thing from RS Links, and then I'm going to go download. So it's already picked, and I can apply to the project. In other words, I can click this box. If I do, then this project will always download to that processor, but I'm not going to do that. I'll just hit download, and downloading program, yeah. Change it from run to program, yes. Now it's downloading. Change back to the run mode. Yes, you have my permission. Change back to run mode. Now we're running. Do you want to go online? Yes, I do. Now, none of these bits are on right now. Now, I could go turn this one on. And you know, I just noticed something. See this stop instruction here? If this was actually wired up to a normally closed push button, the push button would be closed right now and these would be true. But I don't. So I'm going to have to go back and change these to true if off, or I can just toggle them. And now they're simulating field wiring that the normally closed, meaning you haven't pushed the button and the button is closed when it's not pushed. It doesn't close when you push it. It's already closed and it opens when you push it. So right now that's simulating a stop push button that's normally closed, nobody's pushing it. Okay, so we have another couple things here that we would have to do. Right now, if you look at these two rungs, notice that the limit up and the limit down switch, these instructions aren't true. It's saying that both switches are open, meaning that the garage is all the way up and it's all the way down, when we know that's not possible. So let's start with the garage all the way down. So we'll right click and toggle. Okay, now that's pretty much how the garage door would start. Okay, the stop button's not pushed and the garage door is all the way down and it's making this switch. Okay, so something's not right here. What is it? If it's already down, that's because these limit switches are normally closed. So if it's all the way down, this one would be open because it's tripped by the garage door being all the way down and open the switch. This is the one that would be closed because the garage door is all the way down. When the garage door is down, it's not hitting this switch and it's spring-loaded closed. Okay, now we're ready to start. So if we push the up button, right click, toggle, see that bit goes on, which turns on this bit. That's the same bit. Okay, so this bit goes on, so this instruction reads that bit. Remember, this is a condition and this is an action. So this says, this green right here, this says that B300 is on. This is an instruction that reads B300 and is green if it is on. Okay, so the way I can prove that, I would have to make this smaller so you can see that here, control relay up, see, B300, B300. See, that's not true, is it? Okay, but if I, and by the way, I can untoggle that bit because remember, once you push that push button, the relay contact bypasses it so it stays energized. Now, if I hit the stop push button, watch what happens between this rung and that rung up there. See, B300, B300. This is false, that's true. So if I stop this, now that's a spring-loaded button, momentary, so when I say stop it, I mean toggle it off, then toggle it back on. Notice when I toggled it off, it dropped out this relay coil and all of its contacts. This went true and that went false. These read the same bit in memory. This instruction is true if B300 in memory is on. This instruction is false if B300 is on in memory. So we'll start this again, right click, toggle, right click, toggle. That's the same as turning the switch on and off. Push it and letting go. Okay, energizes this bit, which turns on that bit by way of the contact, bypasses the push button, and it makes this go false so you can't start it in the down direction. So if I go here and push on the down by toggling it on, nothing happens, does it? Well, Actually, I cheated. Let me back up here a minute. Okay, we pushed the up button and it's on its way up. Well, what happens when it starts going up? The down limit switch is going to go true because the door is moving up and it's no longer sitting at the bottom on the down limit switch. Now we'll hit the down push button, and of course nothing's going to happen because this interlocking contact from this coil or this bit and its interlocking instruction keep you from turning on this bit and trying to force the motor bit down simultaneously with the up. So what's going to happen in normal operation here? You could hit stop, but it's going to hit the up limit switch. Now, so I did something wrong here because, oh, you know what? It's dropped out the up relay, but I show the down limit switch. Oh, I left this on, that's why. Now, remember, I didn't toggle this back off, so I'm going to cheat here. See, it's not going up or down now. Now, that's the problem of toggling bits and not actually using I/O. So if you can get a regular piece of PLC hardware, whether it's a used Micrologix 1000, 1100, remember the free software only programs the 1000 and the 1100. You're much better off with a piece of hardware where you've actually got push buttons or toggle switches than toggling bits, because this is what you run into. You toggle one on that's really a momentary contact in real life, you know, in a real circuit, and then you leave it on. So I had the down held down when I hit the up limit switch. This relay turned off, that became true, and bang, it immediately started going down. So that would be like telling it to go up and then holding down the down button, and you know what, as soon as it gets up, it's going to start back down. So the operation was correct. Okay, now the one thing we didn't see was what happens when we, and by the way, there's no preset in this timer, so I'm going to go in here, I'm going to put in a short one of 5 seconds. Okay, see, there's a 5-second preset in there. Now I'm going to hit the down button. Okay, and then I'll toggle it back off. And it gets all the way down. Now, see, when you're not going up or down, then the timer times out. So, what's wrong with this is that it gives us an off delay, but it doesn't give us light while the garage door is going up or down. Okay? It only gives us light for 5 seconds after they both go off. Now, timer instructions execute on a false to true transition of the rung, meaning when the rung goes false, this executes. But it doesn't execute again until the rung goes true and then false again. I mean, goes false and then true again. So we need to add logic that will make this light go on when the garage is going up or going down, and for the delay. Now, this controller does not support online programming, so guess what I have to do? I don't need to save it because I didn't make any changes, because you can't make changes online. So I'll just go offline. I always say yes. What it does is it saves the data table values. In other words, what bits are turned on and off. That's what it's saving. It's not saving any logic because you didn't change any. So let's go down to this rung right here. Okay, we want this light to be on for that off delay, and, or is a better word, and I'll drag down this branch around. Put in a true if on. Now I'm going to do something tricky here that isn't up here in the tools it is, but you don't see it. I'm going to right click there and say extend branch up, extend branch down. I'll go down and then I'll grab a true if on and put it, whoops, got down to the end of the rung there and then took off on me. Okay, so if it's going up or if it's going down. So if the relay, if the motor is running the garage door up, it turns the light on. If it's running down, it turns the light on, or during the delay. I will verify that rung. I'll go back to comms, system comms, over here to download. Yes, yes, downloading, 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 downloading. Back to run mode, online. Now, the garage light is on, well, it's not on right now. That bit was on in memory when we left, but when we downloaded and changed the program, it turned around, turned right back off, but it was on for one scan. Don't worry about that. So I'm going to go up here and we'll say that the garage door is down. Okay. Remember, you have to toggle all these bits. You got to remember this sequence because you don't actually have physical devices doing this, and it can mess you up big time. So now I want to run the garage door up. We'll start with it down, which means this is on. Remember, this is spring-loaded closed. So I'm going to turn on this bit, toggle on. I'm going to toggle right back off. Okay, it's on its way up. Okay, notice we've got light because it's on its way up. Now, and by the way, just so we can see this, I'm going to change this to 15 seconds. That way it gives us time to get back down there. So what will happen is, and by the way, as soon as we start going up, the down limit switch changed state. So they're both true when the door is in between up and down. When it gets all the way up, there, see the motor stop. We go down here and we see that we've got illumination because we're in the off delay now. Okay, so that basically finishes up the logic, the basic logic. Now I might think of some more things to add to this. And you literally saw unrehearsed, unscripted, you know, I just did it and kind of talked as I was going, made a few mistakes. Hope I didn't confuse you too much. So this wraps up the logic for the garage door opener. I think we've covered all the bases. If I haven't, I'm sure you all will let me know about it. Okay, that wraps up the third segment, and it might be the final segment. So even though the slide says, thank you for watching How to Program a PLC, Volume 1.2, which would be the third segment, because you had 1.0, 1.1, this is 1.2. I don't know if there's going to be a 1.3, so don't go, well, I guess you might as well go looking for it, but I don't know if there's going to be a fourth segment. So, but I wanted to leave that description on there just in case there is. So if you go looking for it and you don't find it, either there's not going to be one, either way it's not done yet. So one thing I wanted to mention, especially since I pointed up into the tabbed instruction set up at the top in the tool section, there are all these individual tabs and each one is a subcategory of the category instructions. And there's about 70, that's 70 instructions that are available to use with the Micrologix 1000. I doubt we'll do videos on all of them explicitly. However, if you have a copy of the manual that we provide, that we make available for purchase on the plcprofessor.com website, and you can buy the electronic version of it and then download the software, do the simulator, and you can go through all the labs, watch all the videos on all the lab discussions. There is a lab project in that manual that covers every single instruction that you can use with a Micrologix 1000. So there are at least 70 instructions used in the lab projects in that 200-page manual. And by the way, I put the electronic version on there. I will say it is monochrome, grayscale with watermark. So it's not as palatable. It's not as tasty, if you like, as the full color version that is, to get that you have to buy the printed copy. But I put that inexpensive PDF on there so anyone and his brother or sister, mom, dad, uncle, aunt can learn to program a PLC for the price of that PDF. Because remember, you can download the software free. However, if you really are interested in learning to program PLCs and you have some revenue to work with, you should buy the printed version. It's a much easier source of information to work with. Does cost more. Color printing is very expensive, and I printed them in black and white, and they just don't look good. They look much better in color. But the inexpensive PDF electronic copy will do the trick. Download the free software, and for the price of that PDF, you can go through all the lectures, all the videos. So once again, I really appreciate you all watching these videos. Someday, hopefully, enough people will buy something, whether it's the printed version or the electronic version or copies of the disc, and I do sell PLC trainer hardware, meaning a Micrologix 1000 that has been wired up as shown in the how to build demo video. However, I'm thinking of switching to a hardware trainer that is more expensive to build but less work, and that uses a pre-built circuit board switch system that you just slide in and tighten down. Those are about $80, $90 just for the switches. So anyway, for the next, we'll call it volume 2, it may be scheduling air compressors. In other words, writing the logic for a group of air compressors in your manufacturing plant that you want to cycle through on shifts. In other words, you want to run compressor A for 8 hours, then compressor B for 8 hours, compressor C for 8 hours. But if compressor B can't keep up on second shift, compressor C will kick in to keep the air pressure up in the plant. However, that time that C is on during B's shift will be subtracted from its 8 hours when its turn comes up. So many manufacturing plants have more than one air compressor simply because they need more compressed air. Plus, if it stops, they still need compressed air. So you got to have a backup. Anyway, that may be our next choice, or it might be a conveyor system. We'll see. Thank you very much.